So, am I audible, sir? Hello.
Yes, sir. Yes, sir. Audible.
So can I start? Okay, sir. Good morning, everyone. It is my pleasure to welcome you all to this session on Introduction to Virtual Labs and Exploring Laboratory Skill Education with AKTU Mapping. We are honored to have with us Dr. Ashutosh Tiwari, Dean PG and Registrar at Rajkiya Engineering College, Banda. He is a distinguished researcher with a postdoc in nuclear engineering from IIT Kanpur, and he has worked on innovative system software in the US. He is also a reviewer for Elsewhere's Annals on Nuclear Energy and a member of multiple esteemed scientific societies. Dr. Ashutosh Tiwari sir has led various national and international seminars, guided research scholars, and contributed significantly to projects like the DST, TAREE, and MHRD virtual lab development with IIT Kanpur. His expertise spans nuclear safety, thermal barrier coatings, and virtual labs, making him the perfect guide for today's session. Without further delay, let's welcome Dr. Ashutosh Tiwari, sir. Over to you, sir.
Thank you so much. Is my presentation visible? Or- Yes, your presentation is well right now. Thank you so much. So, first of all, I would like to thank Director REC Kannauj, Professor Manoj Shukla sir, PI of the Virtual Lab project at IIT Kanpur, Professor Kantesh Balani sir, Virtual Lab IIT Kanpur team, especially Dhananjay Umrao ji, and the organizing team of this FDP, Professor Ravish Rajput ji and Mr. Rajiv Baghel. So thank you all for providing this opportunity to give the talk in this FDP on use and development of virtual laboratories with virtual reality in education, which is being organized by Rajkiya Engineering College, Kannauj in association with Virtual Labs IIT Kanpur. So, as in my presentation, I have put on two logos, one of Rajkiya Engineering College Banda and other of Dr. APJ Abdul Kalam University. Since there is virtual lab cell, I will tell you in the presentation and in the Dr. APJ Abdul Kalam Technical University, and I will let you know all about the initiatives which virtual lab cell has taken till now, and also what are the activities going on at Rajkiya Engineering College Banda related to virtual labs, and what was our journey for becoming a regional nodal center from the nodal center affiliated to IIT Kanpur in connection to the virtual labs. Also, I would like to demonstrate one of the experiment here, which we have developed in collaboration with IIT Kanpur. So, first of all, we should all know that what this is the virtual lab cell. This cell was established in 23rd of April 2020 during the COVID pandemic time, and these are the members of the virtual lab cell at AKTU. Dean UGSE is the convener, and Professor SP Shukla, Director REC Banda is chair, and I am the co-chair of this. And also we are having on board Professor KV Gangadharan from NIT Suratkal and Professor Kantesh Balani from IIT Kanpur. So this virtual lab cell is doing the mapping of the available experiments on the virtual lab portal with the subjects of different engineering branches of AKTU, and also making recommendations to the board of studies to incorporate these virtual lab experiments. Slides are not changing, sir?
Yes sir, हमें लग रहा है कि स्लाइड्स फ्रीज हो गई हैं, चेंज नहीं हो रही हैं।
ये वर्चुअल लैब सेल आपको दिख रहा है?
नहीं, अभी हमें तो आपका जो टाइटल पेज है वही दिख रहा है, फर्स्ट पेज।
रवीश जी, मैं चेंज तो कर रहा हूँ,
बट फ्रीज हो गई है सर आपकी स्क्रीन।
कनेक्टिविटी का इशू हो सकता है सर।
नहीं सर, एक बार रीअपलोड कर दीजिए सर हटा के।
कैन नॉट चेंज योर
मैं स्टॉप शेयरिंग करके दोबारा कर। अभी दिख रही है आपको चेंज होते हुए?
यस। Now this is introduction to virtual lab cell cards.
हाँ ठीक. So so I was telling about the virtual lab cell at AKTU, and now there is one tab, academics tab, on the AKTU website, aktu.ac.in, where you will find out this virtual lab. And you will click on this virtual lab, you will find out these headings there: virtual lab cell, the virtual lab webinars which we have conducted subject wise, and the virtual lab mapping. So let me inform you that this virtual lab mapping one, when you will click on this, it will download an Excel file containing the mapping of the virtual lab to the different engineering branches of AKTU for even semester. And this virtual lab mapping too is for the odd semester courses. And also this mapping is in the continuous updating mode. So whenever there is change in the course and whenever we found any new experiment, we keep on doing the add-ons to this virtual lab mapping so that it may become relevant to the courses which are going on in the AKTU. Now, let me show you the success timeline, how the virtual lab nodal center at Rajki Engineering College, Banda has progressed. So,
आशुतोष
virtual
सर,
lab, sir.
सर सॉरी टू स्टॉप यू सर, मुझे लग रहा है कि फिर से स्लाइड्स चेंज नहीं हो रही हैं. सो
Oh,
आप एक बार उसमें स्क्रीन फुल स्क्रीन मोड में अगर आप जाएं तो शायद हो सकता है कि प्रॉब्लम ना हो.
मैं कर रहा हूँ, एक मिनट. स्क्रीन ही शेयर करा देते हैं, एक मिनट. अब दिख रहा है आपको?
हाँ, अभी दिख रहा है. एक बार आप चेंज करिए एक दो स्लाइड्स. हाँ, अभी चेंज हो रहा है, अभी दिख रहा है, अभी प्रॉपर दिख रहा है.
ठीक. तो इसको फिर से मैं रिपीट कर देता हूँ कि मैंने व्हाट आई हैव इन्फॉर्म्ड इज कि व्हेन यू विल गो टू द AKTU website and you will, below the academics tab, you will find out the virtual lab here. And when you click on this virtual lab, you will find these three headings. One is the virtual lab cell, other is virtual lab webinar, and the third one is virtual lab mapping. So since we have uploaded this mapping during the COVID pandemic time and the event semester was going on, so the first mapping was for the event semester and the second mapping is for the odd semester courses. And since this mapping is in the continuous updating mode, so whenever we find any new experiment on the virtual lab portal, we keep on updating this mapping. And also whenever there is incorporation of any new course, then we take care of the new courses. And also I would like to invite all the participants here, if they find any update in the mapping, please let us know so that we can keep on updating it. Now, this is the success timeline, how the virtual lab nodal center at Rajki Engineering College, Banda has progressed. So, virtual lab nodal center at Rajki Engineering College, Banda came into existence on 16th of November 2018. And then we were also having the keen interest that how these virtual, since we were using the virtual college, Banda has progressed, we are using the virtual lab, but we were not able to identify how we can make these virtual lab experiments. So we came to know that there is one boot camp is happening at Gujarat University in January 2019. So our team of the students went there, and first we have developed a lab on Stephen's law by the students of Information Technology Department of Rajki Engineering College, Banda. And that lab was hosted on the portal of the IT Bombay. Then we got another milestone that two of our students at the virtual lab, we have formed one virtual lab club, and two students from the virtual lab club were selected for the National Summer Virtual Lab Development Internship at IT Bombay. And then followed by this, we have received a grant for the development of virtual labs, previously MHRD, now Ministry of Education, in collaboration with IIT Kanpur. And still some of the labs are under development in this project. And after success of this, we have organized India's first virtual lab development bootathon on 4th of November 2019 to 10th of November 2019 at Rajki Engineering College, Banda, where approximately 200 participants in the form of 27 teams participated across the country at REC Banda, and we could develop more than 50 virtual lab experiments in this bootathon. After that, we have formed a virtual lab club, and currently around 60 students of REC Banda are actively involved in the development of the virtual labs. And 13 students of the virtual lab club at REC Banda undergone paid internship at IIT Kanpur. And then we came to know about one circular that if the nodal centers are in a process of making new nodal centers affiliated to IIT Kanpur, they will be promoted as the regional nodal center. And then we have put on some efforts, and we were successful in making 22 new nodal centers of the virtual lab, which are currently affiliated to IIT Kanpur. And we have conducted more than 63 workshops till date. So as I was informing that our Rajki Engineering College Banda came into existence as the virtual lab nodal center on 16th of November 2018, we got this mail from Dhananjay Umrao ji, and our college was recognized as official nodal center related to India virtual laboratories at Indian Institute of Technology. So this is the pictures, some of the pictures I have placed here, because this always gives me motivation, and we keep on working. That our team of the students went to Gujarat University boot camp in January 2019, and we have successfully developed one first virtual lab, which was hosted at the IIT Bombay portal. Then this we have received this letter. Aditi Nishad and Mohante in the Melia, two of our students received the summer virtual lab development internship at IIT Bombay. And this bootathon we have conducted from 4th to 10th of November 2019. So what happened? Since this event was going on, and the judgment of Ram Mandir came at that time on perhaps it was 9th of November. So 2 days, last 2 days, 9th November and 10th of November, we could not conduct this activity in the offline mode. So we have planned to conduct this activity in the online mode. And what happened by conducting this last 2 days in the online mode, we got an idea that this type of event, bootathons, can also be conducted in the online mode, and more number of virtual laboratories can be developed, and people sitting at remote places can also participate in these activities. So by this, we started conducting a e-bootathon series, and till now we have conducted 4 different e-bootathons. So I will let you know in the next slides. So this is the inaugural session of the bootathon conducted at Rajki Engineering College, Banda. And these are the 5 students who got the paid internship initially, and now we are having a very big number of the students who are continuously working in collaboration with the IIT Kanpur in the development of virtual labs. And also some of the students from our college are also actively engaged in developing the virtual reality based experiments. Perhaps soon we will be able to get 30 to 40 new virtual reality based virtual lab experiments. So these are the 22 new nodal centers which were formed by us, and now they are the nodal centers affiliated to IIT Kanpur. So and after this we were promoted as the regional nodal center of the IIT Kanpur's virtual labs. So may I ask, the slides are changing now?
Yes, sir, it is changing.
Yes,
Okay.
sir, now changed.
Thank you. So after that, I have told you that we have started the conducting e-bootathons.
So in this series, we have conducted 4 e-bootathons. During e-bootathon 1, the 23 new virtual labs were developed, and in e-bootathon 2, 29 virtual labs were developed, and in e-bootathon 3, 31 virtual labs were developed, and e-bootathon 4, we have developed 41 virtual labs. So, and also when we will explore the virtual lab portal vlab.co.in, which previously some of the speakers in this FDP have also shown, we will be able to know that there are some domains which are not being covered there. For example, this pharmaceutical sciences. So, Meerut Institute of Engineering and Technology, Meerut, has developed 3 experiments from the pharmaceutical sciences, and during the e-bootathon 1, and then from 3 experiments have been developed in the e-bootathon 2 in the food technology and department from HVTU Kanpur and IET Bundelkhand University Jhansi. So what happened due to this encouragement and this platform, what happened, we now IET Bundelkhand University, the Food and Technology Department, is also actively involved in development of the virtual labs, and their students are also getting the internships at IIT Kanpur, and all now they have made several colleges of Bundelkhand University as the nodal centers affiliated to IIT Kanpur, and they have been also promoted as the regional nodal center. So this is how the journey progresses, and the institutes are coming forward, and they are becoming the regional nodal centers and also contributing a lot in the development of the virtual labs. So let me take you to the infographics of the e-bootathon 4. In e-bootathon 4, 79 virtual labs were proposed and 6 teams were participating, and 12 different disciplines of engineering and technology, including the applied sciences, were participating in this from the 21 different colleges, and there were 9 mentors. So this is also one of the big achievement that initially we do not have any person here who can guide someone wishes to develop the virtual labs. Now we are having a very good pool of mentors with us, and this happened successfully with the help of the conduction of the e-bootathons, and these are the domains which we have covered for the development of the virtual labs. We have developed physics, 1 virtual lab, chemistry 1, pharmaceuticals, 4 virtual labs, biotechnology 1, automobile 1, food technology 2 virtual labs, civil engineering 3, mechanical engineering 10 virtual labs, triple E 13 virtual labs, electronics and communications engineering 11, information technology 2 virtual labs, and 30 virtual labs in the domain of computer science and engineering. So what was the significant achievement of the e-bootathon series? That 83 virtual lab simulators were developed, and now we could say that we have also got an increase in the number of disciplines in for which the virtual labs are available, and also we see an increase in the number of mentors. Now we are having 11 different mentors from different colleges of Uttar Pradesh who are continuously guiding the students for the development of virtual lab. So since I'm giving you one glimpse that how the virtual lab development proceeds and what strategy we have adopted during the e-bootathons. So there are overall 5 rounds. So round 0 is the GitHub development, and in round 1 we see that in the lab development process the Bloom's taxonomy is adopted and all the cognitive levels of understanding have been tested or not. And similarly, then we have to propose one round document, and after the formal review of that document, the we get a green signal to start the development of the virtual lab. So whatever experiments we have developed during e-bootathons I would like to inform you that if you can note this website ebootathon.com, it contains number of experiments. Let me take you to that website also, which are developed during these ebootathons. So I don't know why it is taking so much time to open. So is the presentation visible now? Is the presentation visible to you all?
No, your slide is not showing right now.
It is visible now?
No, no, no.
Okay. Now it is visible?
तो स्लाइड विजिबल है अभी आपकी, अभी क्लियर है, अभी दिख रही है। प्लीज चेंज इट सो दैट वी कैन कंफर्म। एक बार
चेंज हुआ?
हाँ, अभी चेंज हो रही है स्लाइड्स।
ठीक ठीक, थैंक यू. So I will take you separately to this website ebootathon.com. It contains the various experiments which were developed in the different ebootathons, and the beauty of this ebootathon.com website is it is only contains the experiments which are especially designed for Dr. APJ Abdul Kalam Technical University. And we are in the process of development of these new labs, and likely to be hosted soon, in a month or two. These our experiments are almost complete, and these are the students from Rajkot Engineering College Banda who are involved in the development of these experiments. So this is for the basics of physics, and this is the basics of electrical engineering labs which are under development. So let me demonstrate one of the experiments from the basics of physics lab and take you to the website vlab.co.in. So let us proceed so that we can see one experiment. So if you, Ravi ji, is the screen visible to you?
विजिबल है कि स्क्रीन आपकी विजिबल है? प्लीज
ठीक.
गो अहेड।
So this is the virtual lab portal vlab.co.in. So if you explore this portal, it gives us information. This is an initiative of Ministry of Education under the National Mission on Education through ICT. And these are the objectives of the virtual lab: to provide remote access to simulation-based labs in various disciplines of science and engineering, and to enthuse the students to conduct experiment by arousing their curiosity. This would help them in learning basic and advanced concept through remote experimentation. And also, this is another objective: to provide a complete learning management system around the virtual labs, where the students, teachers can avail the various tools for learning, including additional web resources, video lectures, animated demonstration, and self-evaluation. So these are the broad area of the virtual labs in which the virtual labs are available on this portal. Electronics and communications labs are there, computer science and engineering labs are there, electrical engineering labs are there, mechanical engineering, chemical engineering, biotechnology, biomedical engineering, civil engineering, physical sciences, and chemical sciences. So let me take you to the labs which we have developed in collaboration with the IIT Kanpur. This is basics of physics lab, which our students and the faculty member team from Rajki Engineering College Banda has developed with the support of IIT Kanpur. So if you click on the basics of physics, it gives it comes introduction. Welcome to the basics of physics lab, and this is the objective of this basics of physics lab. The students will be able to explain the basics of physics. The students will be able to predict the variation of various measurable physical quantities with physical conditions like temperature. Students will be able to analyze the basic laws of physics. And this is the list of 10 experiments. These all experiments belong to the syllabus of AKTU. And since if we are well versed with the syllabus, the practical syllabus of the AKTU, we know that five experiments are to be done from the section A and five from section B. So overall 10 experiments are to be performed. So we have initially designed these first 10 experiments so that if the student is not exposed to the hardware labs, then they can perform these 10 experiments through the virtual lab also and complete the course curriculum requirement. So let me take you to the energy band gap of simulator experiment, and I will try to demonstrate this experiment so that those who are new and have not performed this experiment, they should get the idea how to perform an experiment on the VLab portal. So if we go to the energy band gap of the semiconductor experiment, it gives the aim as to determine energy band gap of semiconductor. Then comes the theory part, and the basic theory is always provided here related to the concerned experiment so that the student who is coming for the first time on this portal and directly performing the experiment can get the basic idea so that he will be able to proceed further. So as we all know that in case of insulators, the region between the highest level of completely filled valence band and the lowest level of the allowed conduction band is very wide, and this is called the energy band gap. So this energy band gap is denoted by Eg, and it is about 3 electron volt to 7 electron volt in case of insulators, and in case of semiconductors, this energy band gap is quite small. So, and we also known as that in case of germanium, the energy band gap is approximately 0.7 electron volt, and in case of silicon, it is 1.1 electron volt. So, and when we connect any PN junction in the reverse bias, a saturation current flows, which is depending on the temperature, and this is the relation which we all know that the reverse saturation current IS is equal to A into T to the power 3 by 2 into E to the power minus Eg upon KT, where A is a constant term, Is is the saturation current in microamperes, and T is the temperature of the junction in Kelvin, Eg is the energy band gap, K is the Boltzmann constant, and also we know that if we take the log of this equation from both sides, it becomes log Is is equal to certain constant minus 5.04 into Eg 10 to the power 3 by T. So if we plot the graph between 10 to the power 3 by T and log Is, so it will give us a straight line graph with negative slope. And if we can calculate the slope of this graph and divide this slope by 5.04, we will be able to know the energy band gap. And this is the simple, very basic circuit for performing this experiment, that we need a power supply of 0 to 20 volt, and a voltmeter is connected in parallel to the PN junction, whereas the micrometer is connected in the series. So this is the basic circuit we have to adopt, and also we came to know that the between log Is and 10 to the power 3 by T, there is a straight line graph with negative slope. So after going through this theory, the student is asked to perform the pretest. So this pretest questions are designed in such a way that if the student has not gone through the theory, he will not be able to attempt these questions. So once the theory part is clear, the student will also able the basic understanding of the experiment and will able to proceed the simulation also. So let us quickly perform these questions. The first one is the plot of 10 to the power 3 by T and log IS for PN junction diode in the reverse bias is. So as we have gone through the theory part, it is the straight line. Again, normally the current in the PN junction during the reverse bias is in microamperes. So we click on the A option. Energy band gap in case of silicon is approximately this. Also, we have gone in the theory that it is 1.1 electron volt, and energy band gap in case of germanium is approximately 0.7 electron volts. So we submit a quiz then. So it is not, it will give us the message that 4 out of 4 are correct. If anyhow we put any question wrong, so we choose the wrong option and then submit the quiz, it directly give us that now only 3 questions are correct, and those questions, those options which are correct get green color, and the wrong option gets the red color. So the student will be able to know that I have not understood the theory part properly. So he needs to go to the theory again and then perform this pre-test. Unless the pre-test is clear, we do not recommend anyone to proceed to the simulation. Otherwise, in the lack of the basic understanding, the student will continuously bother his mentor that the experiment is not working or it is not giving the correct results. So now, uh, after when we attempt the this post pre-test, then we can proceed for the procedure part. Now, when we perform any virtual lab, the procedure which we list here is in such a way that if any student reads carefully the procedure step by step and performs then perform the simulator will definitely work and the student will be able to get the result. And this procedure is entirely different from the procedure which we adopt in the hardware labs. Suppose someone is performing any experiment of energy band gap in the BTech first year lab of physics, then he may say that the instructions given in that lab is entirely different. So yes, of course, the instructions of the virtual lab experiments are entirely different from the hardware experiments. And these procedure part should be adopted step by step. If the student misses any step or the student performs, suppose the student performs the fourth step after the sixth step, the experiment will not proceed. So quickly we go through this so that we can perform the simulation and complete the experiment. So it says that first click the enable power button. So we will note this and choose the correct image. After correct answer, cross the image, click the place container button and then click on the drawing box. Click on battery button and then click on the drawing box. Click on the emitter button and then click on the drawing box. Click on the voltmeter button and then click on the drawing box. Click on PN junction button and then click on the liquid inside container. Click on point button and then click on the drawing board wherever point connections are required. Click on the connect button and then click on the point to be connected to complete the circuit diagram. Click on the undo redo button in case of wrong connections. Select voltage from the drop down button. After selecting the voltage, press the click button. Draw the slider to choose the temperature. Click on the find here button to get the reverse saturation current. Repeat this process to complete the observation table. Click on the calculate data button. Click on the draw graph button. Place the cursor on the plotted graph to enter the value of the first and second coordinate. Click on the first find slope button and enter the value of the calculated slope. Click on the calculate button to get the value of the energy band gap. So these are the 22 steps and these steps are to be exactly followed in this sequence itself. Otherwise, the simulation will not give the correct results. So now let us proceed to simulation, and I will perform this entire simulation in following these steps for you all so that you can get the idea. So initially it was asking that click on the enable power button. So I just click on the enable power button and it is giving one image here and asking that among the following graphs, which graph is plotted for the semiconductors in the energy band gap experiment. So this question again is coming here, and we say these questions as the pitfall questions for the student, so that if the student is directly attempting the simulation and not gone through the theory part, not gone through the procedure part, so he will create a mess of this experiment. So again, we ask a question to check that whether the student has gone through the theory or not. And if the student will be able to answer this question correctly, then the simulation will allow the student to proceed further. So it is asking among the following graphs, which graph is plotted for the semiconductors in the energy band gap. So as we have gone through the theory part, that the graph between the log IS and 10 to the power 3 by T is a straight line graph with negative slope. So definitely the image 2 option is correct, and we click on the image 2. Immediately it gives us message that you choose the correct answer and please proceed further. So we can cut this image, and now this enable power, which was showing the red color here, now it is becoming green, and it is saying that disable power if we want to stop the experiment. Then according to the procedure, we have to click on the place container. I have clicked on the place container and then click on this drawing board, so that virtually a container will come which is having a liquid here, and then we click on the PN diode and then click on this liquid, so that virtually a PN junction diode comes here. We click on the battery, virtually a battery comes here, then ammeter, virtually ammeter comes here. A voltmeter is required also to be connected in parallel to the PN junction. A voltmeter virtually comes here. So these are the points, and these are required when we wish to complete the circuit with the wire. So virtually we can see that if the straight wire can come here like this, and also when the straight wire will come like this, so there should be one point here also. And when the wire is going for this connection, we can please place one point here and one point here. In this way, we can place the points, and then we can proceed to make the circuital connections by clicking the connect. We have to click the connect and then once click here and then click here. So virtually a wire will come here which will join the circuit, and unless the circuit is completely completed, the experiment will not proceed, and it will proceed only when the circuital connections are perfectly correct. So in this way, when the student makes these connections, so virtually he will be able to know that what are the how that the positive terminal of the battery should be connected with the positive terminal ammeter, and also the voltmeter should be connected in parallel. And also, since we are performing this experiment in such a way that the PN junction is in the reverse bias, so the positive terminal of the battery is connected with the N type, and the negative terminal of the battery is connected with the P type. So, and then in order to measure the temperature of the liquid, that what temperature is there with this PN junction, we place a virtual thermometer here. We click on the place thermometer and then click here. So virtually a thermometer will come here. Now, these are the undo and redo buttons. Suppose we have done any step wrong and we want to undo it, we click on the undo button. So the thermometer is now disappeared. We again place the thermometer like this. And when the circuital connections will be properly made, then we will get a message that the simulation has been started. And also this message will give that how many times we have pressed the undo or redo button. And if we click on the reset, this whole diagram will disappear and we have to make the circuital connections again. Then In the procedure, we have read that we have to select a potential difference. So we select a voltage, and there are the five options being given here to the drop down: 1 volt, 2 volt, 3 volt, 4 volt, and 5 volt. So let us take the 2 volt here, and then click on the then click here, so that it gives us message that you have selected a voltage of 2 volt. This 2 volt potential difference is being applied virtually through this battery on the ends of the PN junction. We have to move this slider in order to know that what temperature of the liquid we are applying here. So if we click on the slider and then take the temperature temperature as 5 degrees Celsius, and then we have to click on the find here to get the reverse saturation current. So when we click here, find here, it is giving us the reverse saturation current as 3.030 microamperes. So we can note down this value in some other notepad, that at 5 degrees Celsius, the reverse saturation current is 3.030 microamperes. And we have to place this value here in this table, observation table, that at 5 degrees Celsius, the reverse saturation current is 3.686, 3.030 microamperes. So since we have to take the 8 observations, now what we have to do is we should take the 8 different observations and then place these values here. So another reading for the temperature we are taking as 10 degrees Celsius. Then we click on the find here, and it is giving us 3.686 microamperes as the reverse saturation current. Again, we click here and change the temperature as 15 degrees Celsius. And then click on the find here. So it is giving the reverse saturation current as 4.453 microamperes. Again, we click here, keep the temperature as 20 degrees Celsius, then find the current. It is giving as 5.346 microamperes. Then temperature as 25 degrees Celsius, and then find the current. It gives them current, reverse saturation current as 36.379 microamperes at 25 degrees Celsius. Now we have to take 3 more observations. At 30 degrees Celsius, the current is 7.568 microamperes, and at 35 degrees Celsius, it is 8.927 microamperes. And then finally, at the last reading at 40 degrees Celsius, the current is 10.476 microamperes. So what we have to do, we have to fill these observations here in the table. So we have noticed that at 5 degrees Celsius, the current was 3.030. And then at 10 degrees Celsius, it is 3.686. At 15 degrees Celsius, it is 4.453. At 20 degrees Celsius, it is 5.346. At 25 degrees Celsius, it is 6.379. At 30 degrees Celsius, it is 7.568. At 35 degrees Celsius, it is 8.927. At 40 degrees Celsius, it is 10.476. So these are the 8 observations which we have taken, and also filled these observations in the observation table. If we click on the calculate data here, as mentioned in the procedure, now what is happening? The temperature is already automatically converting here in Kelvin by adding simply 273 to this value. 5 plus 273 is now 278, and 10 plus 273 is 283. In this way, these all temperature values have been changed to the temperature in Kelvin, and then 10 to the power 3 values required for plotting the graph. So 10 to the power 3 by T means 1000 divided by this value of temperature. So if we divide 1000 by 278, it will give us 3.60 approx. So these all the temperature values are divided by 10 to the power 3, and we get these 10 to the power 3 by T 8 values. And we have to also get the log values of the reverse saturation current. So this is the reverse saturation current, and the experiment is also giving us the log values of these reverse saturation current. Now we have to click on the calculate data button. We have done the calculate data. Now we have to click on the draw graph button. So as we plot the draw graph button, immediately a graph between 10 to the power 3 by t and log is appears here. And what we ask our students to please perform this experiment and take the printout of this by taking the print screen, the circuit, and also note down this observation table in the copy, and then plot this graph either through the graph paper or just take the screenshot of this graph, so that and you can paste it on the copy or in the report which you are going to submit. So now, in order to proceed further, since we are supposed to calculate the energy band gap of the semiconductor, and in order to calculate the semiconductor energy band gap, we have gone through in the theory part that we require the slope of this graph, straight line graph between log is and 10 to the power 3 by t. So if we, the beauty of this graph is if we place the cursor anywhere on this graph, it gives the x and y coordinates of the points. So let us take this value as 3.300 up to 3 decimal places only and 0.879. So I enter the value of the first coordinate here as 3.300, comma 0.879, and this is also the care to be taken off that the x and y coordinates should be separated by a comma. Otherwise, the virtual lab will assume that you are only placing the x coordinate, not the y coordinate. Now, in order to know the slope, we should know the another point of the graph, and we place the cursor again, and we can note down this reading as 3.413 and 0.728 to the by rounding off. So it is 3.413, comma 0.728. Then we click on the find slope button so that the slope is calculated, and this is giving the slope as minus 0.748. So this negative sign here indicates that the straight line is of the negative slope. And in order to calculate the energy band gap, we have to place the value of this slope without sign, because sign is only indicating that this graph is of the negative slope. Here negative is to be removed, and we have to place 0.748, and this is automatically being divided by 5.04 in order to calculate the energy band gap. So if we click on the calculate button, it directly gives us the energy band gap as 0.148 electron volt. So in this way, we can complete the simulation, and the student can note down the reading that the experiment which he has performed for this PN junction with these conditions, the energy band gap is coming to be 0.148 electron. So this is how the simulation is performed in the virtual lab. So till here, if there is any doubt, you can ask in the simulation so that I can proceed further. Any questions to be asked in the simulation part? Ravish ji, I'm audible?
Yes, sir. You are audible, sir.
Mm-hmm. Any questions from anybody in the performing this simulation? Okay. So now when we have performed this simulation, we can come to the post test. And if we click on the post test, so the post test questions are designed in such a way that if the student has not performed the simulation, he will not be able to perform the post test questions. So, and in order to go through evaluate the post test questions, he again needs to visit the simulator. So, for example, it is asking the value of current in the PN junction at when the temperature is 60 degrees Celsius and the applied potential difference is 5 volt. So we have to again go to the simulator and keep the temperature as 60 degrees Celsius and the applied potential as 5 volts. So we have to take the applied potential as 5 volts and the slider temperature as 60 degrees Celsius. So it is giving, and then we find the current, it is giving approximately 18.934 microamperes. Now we can answer these questions. 18.934 is, since it is asking approximately, so it is close to this value, 20 microamperes. Then resistance of any PN junction in the reverse bias, it is asking whether it will increase or decrease or remain constant or none of these with temperature. Then also this phenomenon can be performed by calculating the current, what is happening to the current, whether the current is decreasing or increasing. So the student will be able to know that what is happening to the resistance. So as we know that it decreases, so we click on the B option, and the value of the Boltzmann constant in EV per Kelvin is, again the student has to refer to the theory part to answer this question. And as we know that this is the B option is correct for this. Also, it was explained in the theory that microammeter is connected in series and voltmeter is connected in parallel with respect to the PN junction. So a student has to again check this, that microammeter and voltmeter are how they connected. So it should be series and parallel. And then we have to submit the quiz. So we are getting that all the 4 questions are correct. So these questions can be correct only if the student has gone through the theory part, read the procedure properly, and performed the simulation experiment properly. Now, if we wish to see that what are the databases and what are the formulas working behind these experiment, and where from these data has been taken, so we can click on the references, and these are the references which can be easily downloaded by clicking simply on these links, so that the PDFs will be downloaded, and we will be able to see that what is the data, actual experimentation data is available on these references. After performing the virtual lab experiment, we always ask our students, or wherever we give the workshops, to please give the feedback here. So I would urge all the participants here to please click on this experiment, that go to the VLab.co.in, perform this experiment, basics of physics, and please share your experience and give this valuable feedback. So these feedback continuously being monitored by the central team, and we keep on progressing and removing the bugs. And also there are 2 buttons provided here in all the experiments: rate me and report a bug. If you are not in a condition to perform the experiment properly, if the code is not working or some other glitches are coming, you can report a bug here. And if you want to rate the experiment, that what is the rating out of these 5 stars? So this 4 stars is showing the overall rating till date. So depend, and this keep on changing. So you can rate the experiment, you can give the feedback, you can report a bug also. And in order to perform the experiments here in our college, what we do, we prepare assignments based on these virtual labs in the Google Classroom itself, and ask our students to perform the virtual lab experiments through the portal VLab.co.in, and then attempt the assignments on the Google Classroom so that we can get the record of the students who have performed this experiment and who has not. And also, we ask the students to please upload a report of the performed experiments in the form of PDF that can be in that same Google Classroom that can be treated as the assignment of the student. So in this way, the students are continuously performing the experiment and doing this part also. And some of our students are also what they are doing, they are performing this virtual lab experiment. They are also performing the hardware experiments in the physical labs and then making a comparison that what is the error which is being coming in this experiment or that experiment. And some of the students also publish this data in various conferences by comparing these labs, virtual labs with the hardware labs. And whatever we have in collaboration with the IT Kanpur, we have developed around 150 such experiments. And but these 10 experiments are hosted in the first phase and 20 are coming in the next phase, likely to be uploaded in the month or two. And remaining the improvement process is going on. So in near future, these experiments will come. And I urge all of you to please join us and support this initiative so that we can also, if you find any bug, you can directly write an email to us or you can make a call by taking our numbers to the organizers so that we keep on improving and this virtual lab initiative can be used for the welfare of our society and students. So this is all from my side, and I would ask anyone if there are any questions. So I will be happy to answer them. Ravish ji, am I audible?
Yes, sir, you are audible.
Hmm. So any questions are there? Any questions from anybody? So perhaps no questions are there. Ravish ji, can I finish or wait?
Fine, sir, fine. Everything is understandable. Thank you. Thank you, sir. I extend my heartfelt gratitude to Dr. Ashutosh Tiwari, sir, for sharing his expertise and valuable insights. A special thanks to all the participants for their enthusiasm and engagement. We hope this session has provided you with a clearer understanding of virtual labs and their role in modern education. With that, we conclude today's session. Wishing you all continued success in your learning journey. Thank you and have a great day.
Thank you. Thank you all.